Okay, we're going to skip this first section, okay? And then we're going to just start by being right here, okay? I'm going to go through and we're going to walk through solving these, and then we're going to graph the solutions on a number line. We've already done this before, but what I'm going to do is we're going to use this to kind of emphasize the next step on these types of problems. A lot of times in math, we go forwards where we solve things, and then we reverse it and we try to go backwards and write equations of things. Okay, and that's what we're going to wind up doing today. We're actually going to go backwards and write equations. Make sense? But before we do that, let's go forwards and have a good understanding of what to do. Right? All right, so here we go. We're going to first solve number 7. So we split it, right? Same exact stuff on the inside. Same exact stuff on the outside. Just drop the absolute values. Right? Then we do or. Y minus 4 equals the negative 4 on the opposite side. And we're going to solve those two equations. We get plus 4, we get y equals 8. Or plus 4, we get y equals 0. Then if we graph those on a number line, guys, okay, we put 0, plot 0, put a dot, 2, 3, 4, 5, 6, 7, 8, and then plot 8. Okay? Here's my question. I want to ask you 2 questions about this to kind of deepen our understanding of what we're doing. Okay? What is the midpoint of the solutions? What's the midpoint of the solutions? What's halfway between? Where's the middle? Yes, sir. 4. Does anybody need an explanation as to how to find 4? You can count from 0 to 8. Halfway between is 4. You count 8 spots from 0 to 8, then count 4 spots, and you find the middle, which happens to be at 4. That's it. Okay, here's the second question. What is the distance from the midpoint to the solutions? What's the distance from the midpoint to the solutions? What's the distance from here to here? What's that distance? 4? Okay. There to there? 4? Okay. Let's go to the next problem. Just solve it. X plus 3 equals 2. Drop the absolute values. Or x plus 3 equals negative 2. Right? Solve them both. Minus 3. X is negative 1. Or x is negative 5. Plotting those 2 points, and then we're going to answer those same 2 questions. Plot negative 5 there. 4, 3, 2, 1, negative 1 there. Okay. All right, let's ask those same 2 questions. Where's the midpoint between negative 5 and negative 1? Just say it. Negative 3. Yep, negative 3. What's the distance between that midpoint and one of the solutions or the endpoint? 2? 2. Okay, let's do it again. Let's put it again. Minus 2. Or same story. We get, wait, that's a positive 1, isn't it? Same story, we're going to graph it. It should be a positive 1. 0, negative 1, negative 2, negative 3, negative 4, negative 5. Again, same question. What's the midpoint? What's the midpoint? That whole distance is 6, so midpoint's going to be 3 away. So negative 2 is the midpoint. And what's the distance between them? 3. Okay, Here's my new question for you guys after all that work. Connect what we just did here with the equation. If we're going to go backwards and we're going to write equations, we need to be able to take a look at a solution and get back to the equation. There's a distinct pattern that's created. Talk with your row partner about what you think the pattern is. Okay? Essentially try to figure out how to go backwards, how to go from the number line or the solutions to the equation. Okay? Take a second. Okay, again, the midpoint wound up being what was inside the absolute value bars, but it was the opposite of what the midpoint was. So if the midpoint was positive 4, inside the absolute value bars is a negative 4. If the answer was negative 3, inside the absolute value bars was a positive 3. That all make sense? The distance from that new midpoint, okay, from that new center, actually, from that new center is better, it's better referred to as, the answer to that is the distance, right? Distance, that absolute value is now the distance from the new center. If you want to kind of stretch it out with the definition of absolute values. Anyways, so it's the answer, it's the answer. All right, so now let's try to reverse it. Okay? Let's try to reverse it. So we have this. 8 and 2 are the two solutions. Let's write an equation. Let's plot. Picture usually helps. So negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what did we have to do to ask ourselves after we had that? We said, where's the midpoint, right? We got to find that midpoint. Where's the midpoint? Between negative 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Distance is 10, so it's 5 away. 1, 2, right there. 3 is the midpoint. What's the distance between the midpoint and the endpoints? So when we do our absolute value, our answers were in x. So it's x. It's the opposite number than what's in the midpoint. Right? The midpoint was positive 3, so it's going to be negative 3. And the answer is the distance from that new center. Essentially what we wind up doing is, here's a way to think about it. The stuff inside the absolute value, the minus 3, is like a moving of the center of the absolute value. The center of an absolute value by itself is 0. But when we minus 3, it actually moves or shifts that center a little bit. Does that make sense? Kind of shifts it over. But the 5 still represents a distance. That 5 represents the distance from that center, that new center in particular. Okay? A little weird to think about that way. Okay, go ahead and do these two, please.
So I would plot out to see what it looks like. So negative 6, negative 5, negative 3, negative 2. And I would say, okay, where's the center? I would say, okay, that's the center right there. And that would be negative 4. So inside, so was the center, the new center of the absolute value. But we do it the opposite sign, right? And the outside was a positive 2. So we go, the distance, the new distance is 2. Yeah. So when we do this guy, I would start at 5, 6, 7, 8, 9, 10, 11, 12, 13, halfway between